It screws me up. I have to do u and v, but I'll put out to the side that it equals f prime or whatever, but I have to start with u and v first. I'm sorry. Okay. Yeah, I know. Well, I learned u and v. I never did the f and g, so. Alright. Okay. Well, we know whichever function we pick, one we're going to have to integrate, one we're going to have to differentiate, right? Okay. Do you know what the antiderivative of the natural log is? The antiderivative of the natural log? No. So the one, since you don't know what the antiderivative of natural log is, you can't pick that to be your g prime or your dv or whichever way you do it. So it has to be the one that you differentiate, right? So u is going to be your ln of x. So what is du? What's the derivative of the natural log? 1 over x. And so then my dv has to just be x dx. And so my v, antiderivative of x squared over 2. Okay, and a lot of people recognize that you had to do integration by parts, but y'all flipped these. Okay, the derivative of the natural log is 1 over x, not the other way around. Okay, a lot of people pick the dv or the g prime to be the natural log of x, but you don't know what the antiderivative of the natural log is.
So dv is the natural log of x is. I don't know.
Wait, how did dv change to x?
Okay.
That's a B.
This is a v.
Oh.
That's why the du and the dv thing is confusing for me.
Okay,
V's
so-
and u's?
I use v's and u's. This is f, and this is g prime. So this is your f and your g prime. So this is actually your f prime, and this is your g. And you could fill it in from there. Okay. The formulas are the same exact thing. You can use f prime or you can use u. They mean the same exact thing, and the formula is the same exact.
So the second function you always do is derivative.
Not always. It just depends on how this is written. Like I could have swapped that and told you natural log of x times x, so you can't really say. So it's just a matter of identifying which one do I know the antiderivative of, which one do I not, okay? Or which one is going to disappear when I differentiate them. Does that make sense? All these just come from doing a lot of practice, memorizing what your antiderivatives and what your derivatives are, and just practicing, seeing what works, okay? So formula we have, it's going to be uv minus the integral of v du, or fg minus the integral of g f prime. Alright, so plugging it in, uv, we're going to have x squared over 2 times the natural log of x. Everybody see that? My v and my u, or my g and my f, minus v du, which is g f prime. So that's going to give me the integral of x squared over 2 times x, or times 1 over x, dx, right? And it didn't matter which way I wrote that. I could have written it 1 over x times x squared over 2. Doesn't matter. So it's just multiplication. So you can flip them around. Switch.
Yeah, just take that out.
Okay. So simplifying it a little bit, minus, what can I take out?
1/2.
I can take out a half. And so what does that leave me on the inside of the integral? X squared over x. Over x dx. Everybody understand that? X squared over x. What's x squared divided by x simplified to? Just x. So x squared over 2 times the natural log of x minus 1/2 the integral of just x dx. And a derivative of x,
1.
it's 1/2 x squared. So that gives me x squared, natural log of x. I'm just going to put this all over 2. Minus x squared over 2 times a half.
1/4.
X 1/4 x squared or x squared over 4 plus some constant. All right. You ready to?
Cool.
All right. So the second one, we have 1 over x squared minus 1. Alright, I saw a few people try to change this to x squared minus 1 to the negative 1 power. The problem with that, if I have x squared plus 1 to the negative 1 power, and I'm taking the antiderivative of that, don't you add 1 to this power? Then you get 0. So that makes it 1, and that's not correct. Okay, so we couldn't do it that way if the power is only 1. So what's another way I could do this?
Yes.
Partial fractions. How can I break this up to where it is partial fractions?
A over x plus 1 plus b over x minus
Very good. You have to break up the bottom. This plus 3,
You can just make it an integral.
right. We have the sum and difference rule for integration just like we do for differentiation. So I can just break this up as the integral of 1 over x squared minus 1, factoring it, x plus 1, x minus 1, dx, plus the integral of just 3 dx.
How you gonna do that? Because it's factor out.
You could just factor this out. This is the difference of squares. It's one polynomial that you should have memorized. It makes things a lot easier. Another way, this isn't the only way we could have done it. I saw a few people do it. What's another thing you could do for that?
Put 3 over x squared minus 1.
You do that?
No?
No, because this is just addition, not multiplication. But yeah, you could do a trig sub. What trig sub would you use?
Secant squared.
Secant squared, because tan squared plus 1 is secant squared, so secant squared minus 1.
Sorry.
So you couldn't do cosine?
No, because for cosine, right? And so to get sine squared or cosine squared minus 1, subtract 1 from both sides and then subtract off one of mine. So say we subtract off sine squared, give me sine squared minus 1 is equal to negative sine squared, which I mean it's doable, but it makes things funky. I don't even think it's doable. It might be doable. I'm really not sure. Okay, but does everyone understand this so far? Okay? We could do it trig sub, but I think this one's more efficient, a little simpler. Alright, so breaking this up, this part right here, we rewrite how?
A over x plus 1.
A over x plus 1
Plus b over x minus 1.
plus b over x minus 1 is equal to what?
1 or
1 over
1 over x squared minus
1 over x squared minus 1. So do the whole, multiply both sides by x squared minus 1,
Wait, how does that turn into 1 over x squared minus 1?
because we took 1 over x squared minus 1 and we're breaking it up into partial fractions.
Okay.
So this has to be equal to this, otherwise we didn't do it right.
Oh, okay.
Right? That's the whole point of partial fractions. Exactly.
Oh,
I just do the same thing as a cross multiply.
I see.
Right, yeah, and that's essentially what we're going to end up doing. So we're multiplying both sides times x squared minus 1.
Okay.
Over here, that just gives me 1. Here, like Kilo said, multiplying this side by x squared minus 1 is essentially the same exact thing as doing cross multiplication and combining the two fractions together. So this is going to give me a x minus 1 plus b x plus 1. Okay, and just going through simplifying, ax minus a plus bx plus b is equal to 1. break them up so you can get all your x's together, all your just regular constants together. So I'm going to put together ax plus bx and pull out the x. So I have a plus b, x, and then plus b minus a, however you want to do it, is equal to 1. So my coefficient for x over here is a plus b. What is it here? What's the coefficient for x on the right? There isn't one. There is no x on the other side, so x actually has a coefficient of 0. So I have a plus b is equal to 0. This is the other way of breaking up fractions. I know we usually do them. What do I put in here that makes it undefined? -1, +1. This is the other way of doing it, breaking up for the coefficients. So my coefficient for x is 0. B minus a is just my regular constants. So their coefficient, or what they equal to, is 1. Solving the systems, I get a, solving this one, I get a is equal to -b. So plugging in -b for a, I get b minus -b, so b plus b is equal to 1. This 2b divided by 2, b is equal to 1/2. Right? Oh, okay, hang on. Okay, so I have a plus b is equal to 0, right? Solve it. I solve for a, it doesn't matter which one you solve it for. So a is equal to -b, right? And then I went into my second equation and just plugged it in, which would give me, Ted doesn't like the arrows, but b minus a is -b, so minus -b is equal to 1. Makes it positive, so it gives me b plus b is 1. B plus b is 2b, so divide by 2, b is equal to 1/2. Yes? Alright. The problem with that is it doesn't always work. Okay? It doesn't always work. It works for ones where our root is only appears once, but if you have like x plus 1 squared times x, that x plus 1 squared appears twice, so it doesn't work that way when you try to plug in numbers. So this is the failed proof, works every time way to do it. Now that I know that b is 1/2, just plug b back into any equation. So I have a plus 1/2 is equal to 0, so what does a have to be?
Negative 1/2.
Negative 1/2. Alright, so coming back, so we'll go right here. So now I'm integrating. I have a over x plus 1, so this is -1/2, so I'm just going to pull the -1/2 out. 1 over x plus 1 dx plus 1/2 the integral of 1 over x minus 1 dx plus the integral of 3 dx. Does everybody follow that? I just pulled out the 1/2s. We good? Okay, so antiderivative of 1 over x plus 1, the natural log. So this is -1/2, the natural log of x plus 1, plus 1/2, the natural log of x minus 1, plus 3x, and then plus some constant. Right? Everybody follow? Questions?
Don't you be.
Which other way?
It's,
You want me to show you the trig sub? Alright. Alright.
Yeah, go ahead.
Hurry. Ted's gonna be mad. All I did was get through the quiz. Well,
I got them. They'll be on Facebook.
okay. No, yeah, that was what I was supposed to remind you all about. I'll remind you in a second. Trig subway. Still, I'm gonna break it up. The integral of 1 over x squared minus 1 dx plus the integral of 3dx, which I know that's just 3x, so I don't have to worry about it. What trig sub did you say I need to do? So I'm going to say x is equal to secant theta. So dx is equal to secant theta, tan theta, d theta. Right? Yes?
Yes.
Alright. So just plugging it in. X is secant theta, so this is x squared minus 1, which is tangent squared, so it's going to give me the integral of secant theta, tan theta on top. Thank you. Over tan squared theta. Right? So this tan cancels out. Tan cancels out on the bottom. Gives me the integral of secant theta over tan theta d theta. Right? I saw a few people do this. If you break this up into sine and cosine, what does secant equal to in terms of sine and cosine? 1 over cosine. So this is the integral of 1 over cosine theta over, what's tan? Sine over cosine. D theta. And then some magic algebra. 1 over sine, which is cosecant. The integral of cosecant theta d theta. Which you remember your trick for integrating secant? What's the trick? It's in your notes.
Cosecant plus cotangent.
Yeah, exactly. You're going to multiply cosecant times cosecant plus tangent over cosecant plus tangent. It's the same exact.
Oh, that's it?
Alright. In your notes, there's a trick. In your notes, I'm not giving you anything away, to integrate secant theta d theta. It gives you a hint to multiply secant times secant plus tangent over secant plus tangent. What's secant plus tangent divided by secant plus tangent?
1.
1, so you're not changing anything. It just makes it really easy. So what's secant squared? Or, what's secant times secant? Well, secant squared. What's the derivative of tangent? Secant squared. What is secant times tangent? What's the derivative of secant? So it's just a natural log problem. Same exact thing with cosecant. If you multiply it times 1, namely cosecant times cotan, or cosecant plus cotan over cosecant plus cotan, comes out the same exact way
Does it only work for those two?
for those two. Because of this right here, it becomes the natural log. Which I'm not going to do. That trick's in your notes, so y'all can finish that. Yeah. And then if you do it that way, don't forget about your plus 3x on the end. Yes? Okay, the third one, tan cubed. Ideas? Break it up. Break it up into what? Tan squared, x and tan, x dx, and from there, the identity. What is the identity for tan squared? It's secant squared minus 1. So many people started out with it, but if it helps you, write out what your trig identities are, and then manipulate them from there. Tan squared plus 1 is secant squared, so tan squared by itself is secant squared minus 1. So this is the integral of secant squared x minus 1 times tan x dx, which is going to equal, I'm going to distribute tan, the integral of tan x secant squared x dx minus the integral of tan x dx. Yeah? Alright. There's two different ways we can integrate this right here. What are they?
Substitution.
U sub. Yeah. Well, that's the only way, but there's 2 different ways we can do a u sub. Alright, so u sub, what can I pick for my u? Tan y.
Because it equals, the derivative equals secant squared.
The derivative of tangent is secant squared. It's right there, perfect, beautiful little u sub. The other way you could have broken it up, I saw a few people do it, is what? How else could you have broken this up? Saw a few people do it. Secant, secant, tangent. Okay, some people broke up the secant to be tangent, secant, secant. Pick u to be secant. What's the derivative of u? Secant tan. So you still have it up there either way it works. So just doing it this way, letting u be tangent, it's an easy u sub, you know how to do it. U equals tan, du is secant squared. So it's antiderivative of u, which is 1/2 u squared, so it's 1/2 tan squared. Right? Makes sense? How do I integrate tangent?
Sine over cosine.
Sine over cosine. Break it up. So this is, we know this is tan squared x over 2. This is sine over cosine. What do you see you can do with that? A u sub. It's the natural log. Okay? Remember the way we identify a natural log is that the derivative of the bottom is on the top. What's the derivative of cosine? Negative sine. Okay? So this is actually, in short, I'm not going to work out all the steps, but since it's negative, this becomes positive, natural log of cosine. Cosine x. Okay?
So you just take the bottom of it?
You just take the bottom of it. So you remember, whenever we take the derivative of stuff like, whenever we take the derivative of something, natural log of x, what's the derivative of that? 1 over x. Why is it the derivative of 1 over x? Why is it 1 over x though? Because you take whatever's on the inside on the bottom, and the derivative of it goes on top. Derivative of x is just 1. So if I have natural log of cosine, the derivative of that, I'm going to have cosine on the bottom. Derivative of cosine is negative sine, which is our integral back. Okay? Questions? Moving on really quickly. Do what? Do y'all have questions about that? Alright, so in the fourth one, we have x cubed times square root and 9 minus x squared, something like that.
Yes.
Alright. Alright. What? Trig sub. Which trig identity could you use?
1 minus tan, 1 minus tan.
Very good. 1 minus tan?
Square.
How you gonna get that?
1 minus
Okay, because if we use one of our trig identities is 1 plus tan squared x is equal to secant squared, right? So if I subtract 1 from both sides, I have secant squared minus 1, not the other way around. Okay? So if I use cosine squared plus sine squared is equal to 1, subtract off either one. Usually people plug in sine and get cosine, but it's not going to matter. So I'll say cosine squared is equal to 1 minus sine squared. Right? So now that looks pretty much the same thing as this. Some number minus my trig function squared. So what should I let my u be? Or what should I let my x be? 3 sine. Very good. 3 sine theta. So what's my dx?
3 cosine.
Just 3 cosine. Theta d theta. So now just plugging in I get x cubed, which is going to be 27 sine cubed theta, right? Times the square root of 9 minus x squared, so this is 9 sine squared theta. And a lot of people did this correctly, but left off their dx. It's going to be really difficult to integrate without that dx there, or really easy. Like, either way, it's not good. So times 3 cosine theta d theta. Everybody follow? Yeah? So clean this up a little bit. I'm going to pull out the 3 and the 27, so it gives me 81 times the integral of sine cubed theta cosine theta times the square root. In here, what do? Inside my square root,
Take out the 9.
factor out the 9, gives me 1 minus sine squared theta. And we have d theta still at the end.
Sorry, where did that 27 come from?
Because it's x cubed, and so I have to cube this whole thing. 3 cubed is 27. Okay? And then I got the 81 from 27 and 3 gives me 81. What's up, Jordan?
Why do we use 3 sine theta as x?
Because I need this, I need to be able to condense this down to look exactly like this, so that I can use a trig sub. If I just use sine, I'll have 9 minus
Oh,
sine squared, which I can't do anything with the 9, so I have to have that 9 in there to be able to factor it out so that it looks exactly like my trig identity. Does that make sense? What's up?
you couldn't use 3 cosine.
You could use 3 cosine, and you'd come out to a relatively the same integration. Your answer might look a little bit different, but it'll be the same. Okay? Alright. So 1 minus sine squared, cosine squared, square root of 9 cosine squared, 3 cosine. So I'm going to pull a 3 out. This gives me 243 times the integral of sine cubed theta. I had cosine, so this is cosine squared theta d theta. And from there, we've integrated this a million times. What can I do with it?
Break apart sine.
Break apart sine into what?
Sine squared sine.
Alright, so the 243. So we're going to do sine theta cosine squared theta times sine squared. Does everybody see how that got broken up? I have sine cubed, so I just broke it up sine, and then I still have my cosine squared, and I'm just going to put sine squared up. And sine squared is what?
Cosine minus, 1 minus cosine.
1 minus cosine squared. Okay? 1 minus cosine squared. 1 minus cosine squared theta d theta. Distribute. So I get 243 times the integral of sine theta cosine squared theta minus, this 243 times everything, the integral of sine theta cosine to the 4th theta d theta. Does everybody understand that? Followed that? Okay, from here, both of these are what? Just u subs. What are you going to let your u be? Cosine, because the derivative of cosine is negative sine, so we can work with that. Okay? So this, after I do a u sub, I'm going to get 243 times, it's going to be negative cosine to the 3rd over 3. And this will be negative cosine to the 5th over 5, so plus cosine to the 5th over 5, plus some constant.
But wouldn't that first one be cosine to the 4th over 4? That negative cosine to the 4th over 4? Or is that's 2?
2.
Plus 3.
Alright, so whenever we do trig subs, what's the very last thing I have to do?
Change it back to x.
Turn it back into x. So I know that x divided by 3 is sine of theta, right? Because x was equal to 3 sine theta. Divide both sides by 3, I get x over 3 is sine theta. Everybody follow that? Draw my triangle. Sine of this theta is x over 3. Does everybody see where I get this from? Where I get the x over 3? So this is opposite of our hypotenuse. So this is x3 here. Do Pythagorean theorem. A squared plus b squared is c squared. So it's going to give me 9 minus x squared, which whenever you do your triangle, you should get your original trig sub that you did. We had the square root of 9 minus x squared. I have 9 minus x squared here, so that's one indicator you did it correctly. So cosine of theta, which is what I need, is going to be adjacent over hypotenuse, so you just plug back in the square root of 9 minus x squared over 3 for all your cosines. Right?
Yeah.
No?
Oh, you plug in the square root of 9 minus x squared for the cosine.
Right, because sine is opposite over hypotenuse. What's cosine?
Adjacent over.
Adjacent over hypotenuse. And so just getting that off of our trig, or off of our triangle, here's theta, adjacent, it's the square root of 9 minus x squared, over hypotenuse is 3. So I'm just going to take this whole thing, and everywhere that I have a cosine, I'm going to stick it back in there. So this one would be square root of 9 minus x squared over 3 cubed. This one would be that to the 5th. You just plug it back in. Right?
Yeah.
Yeah.
I'm not something wrong. But that seems like a lot of work to do like in a short period of time.
Well,
You
you
know,
do it a few times and
it'll quicken up.
it quickens up. It quickens up. Alright. We only have a few minutes left, which means we don't have time to put problems on the board. Very sorry. So how are y'all coming with the hyperbolic? That is due on Friday. Okay.
It's working its way down to me.
You want to see some? Just I'm not gonna do them for you. Not gonna do them for you. No.
Tell.
No. It's on video.
I'll
You're not gonna tell.
edit it. Yeah. Alright. Cut it off.
Break out the bribery money.
Yeah.
I'm just kidding.
Okay. The hyperbolic functions. I'm not sure if y'all remember from Cal 1. We never did the hyperbolic functions in Cal 1, but whenever we did the trig inverse, differentiating them, we had to go through all kinds of crazy stuff, do your triangles, and do logarithmic differentiation, all that fun stuff. You remember that? We don't actually. No, nobody. Not feeling it. All right, that's cool. With the sine hyperbolic functions, there's an actual definition that you can plug in to be able to solve each one of these problems that you have to do. So it's not like you're really working with a trig function. You're working with e to the x, just differentiating e to the x, which the derivative of e to the x is, so it shouldn't be that bad, right?
No.
Okay, so we have that sine hyperbolic is e to the x minus e to the negative x over 2. Cosine hyperbolic is e to the x plus e to the negative x over 2. So all you're supposed to do on the first section is just to prove the identities. The first one says that cosh square root of x minus sinh square root of x is equal to 1. You know what the cosine
So you just plug in e to the
You
x,
just-
that minus that one, and then prove that.
Yeah, you're going to plug in cosine here, e to the x plus e to the x over 2 squared minus e to the x minus e to the negative x over 2 squared, which then you have two fractions, but if you square this, what's 2 squared? What's 2 squared? So you're combining two fractions that already have a common denominator. So you're going to get something over 4 minus something over 4 is equal to 1.
That's easy.
So you combine your two fractions, you have something over 4 is equal to 1.
We
Magic
can
out.
do this.
You can do that, okay? And the following two are just like that, okay? You have right above this, if you're looking on page 55 of your notes, you know what tan is. It's sine over cosine. So for number 2, proving 1 minus tan hyperbolic squared is equal to secant hyperbolic squared, you're going to do the same thing. Manipulate your actual definition. So tan,
You just put that whole thing of sine
Right.
over the whole thing of
it's
cosine.
this over this.
And that would be just multiplied by this.
Yeah. And so it's straight algebra. Every bit of this is straight algebra. And differentiating e to the x, which you know how to do. On the second part, this is the part where you actually have to get into differentiating it. The first one says that the sine hyperbolic, the derivative of it, is equal to cosine hyperbolic. So sine of h prime is equal to cosine hyperbolic of x. So this is actually e to the x minus e to the negative x over 2 is equal,
Would it be prime now?
yeah, prime, sorry, prime.
Is equal to e to the x plus e to the
Right. Right, so simple derivative. We have a function, constant times a function. You'll remember all your derivative rules? What constant am I multiplying times this function? A half, pull a half out. And then you have e to the x minus e to the negative x. Prime, derivative of e to the x. What's the derivative of e to the negative x? Negative e to the x,
Oh,
okay? Negative, e to the negative x. The derivative is negative e to the negative x, right? So what happens to this minus? Okay, it's just simple algebra and taking the derivative of e to the x. So those should not take you long at all. They are due on Friday. I believe your test is a week from Tuesday. Let me double check that. Hang on, let me make sure that I didn't not tell y'all what I was supposed to tell you.
Next Tuesday. It's true.
It's true.
Hearing that bell reminds me of Elmer and Smallville. What happened to those days? Smell like the pasture.
Yeah. Alright, test the week from tomorrow. Stay off the streets.
I'll run.